Welcome to Aryabhat Center for Theoretical Physics. This is another video on this lecture series called Quantum Mechanics 1, and in this video I am going to explain what we call how to combine amplitudes. In the last few lecture I have explained what do you mean by probability amplitudes, and probability amplitudes follow what we call superposition principle. So if psi is the probability amplitude 1 and psi 2 is the probability amplitude 2, then we can combine psi 1 and psi 2, and this linear combination is also a what we call valid probability amplitude. So how to combine probability amplitude? This is the experiment, what we call double slit experiment. Where S is the source which can fire electron, and in front of this source is two slit 1 and 2, and there is a screen X. Electron can either travel through hole 1 or either it can travel through hole 2 and will reach at X. And this is the graph, probability graph when 1 is open and 2 is closed. This is the graph, probability graph P1. Again, this is P2, and this is the graph when 1 and 2 both hole is open. So you can see that it deviates from the classical interpretation. This is the strangeness of what we call quantum mechanics. Generally, according to classical interpretation, this should be like this one, combination of P1 plus P2, but it will show you the interference pattern. So this is how quantum mechanics different from the classical mechanics. So now how we can so probability of electron traveling from source S to X is square of the probability amplitude, square of the probability amplitude. So probability of electron reaching at X is the square of probability amplitude, and using the Dirac notation, we can write as this in the bra and K term that electron leaves at source as electron arrives at X. This is how we write the probability amplitudes according to Dirac notation, or we can better write in a compact form like this one, as from source S to X. And suppose if both hole is open and probability of electron traveling through hole X is phi 1, probability of electron traveling from hole 2 is phi 2, then we can write that total probability is equal to phi 1 plus phi 2 square of the sum of these two probabilities. So now we can write when both holes are open, then we can say that X as when both holes are open then we can write individual through 1 plus x as through 2. It means if there are multiple paths to reach, there are multiple paths for arriving any particle to the from the source to the destination, then we can write the total probability of reaching the path is sum of all possible paths. So electron is originating from S and reaching at X. When both holes are open, probability of electron originating from X and reaching at X when both holes are open is equal to sum of the individual probability. So S to X when only first hole is open, S to X when second hole is open, and we can write as when only one hole is open, then we can write that as to 1 and again 1 to X. You can see that we have wrote the probability amplitude for the hole 1 is equal to electron from S to 1 is the hole 1 and again 1 to X. This is the this is for the hole 1. Again we can write X through hole 2. We can also write the same way. Now we plug this one into this and we get both open is equal to you can see that probability of reaching at a specific location is equal to sum of all possible path. Now, and suppose instead of 1 and 2 there are another hole like this one. So electron has to cross not only hole 1 and 2 but A, B, C, D. So how we can write the probability amplitude for this one? So we can write probability amplitude like S to 1, source 1 to hole 2, again from hole 1 to A, again from A to X. Same way from S to 2 and 2 to B and again B to X dot dot dot. So it will be the sum of all possible path. So we can use the summation convention and we can say that I is equal to 1 and 2 and alpha is equal to A, B and C equal to, we can say that X alpha and alpha I S. This is how we can write the probability amplitude for the multiple path, and this is by using superposition principle. So this is the this is how we can combine amplitudes by using superposition principle. And remember, probability of finding a particle at location x is square of the probability amplitude. So this probability for finding at probability of electron to finding a particle x is square of this amplitude, and total probability will be square of the all these amplitudes. Now suppose there is a particle which has definite energy and which is going in the empty space from point R1 to R2. Then how we can write the probability amplitude for this one? So from what you call R1 to R2, it is simply e to the power IP R2 minus R1 divided by h bar to R2 minus R1. This is how we can write, or instead of R2 minus R1 we can say R1 to h bar R1 2, and particle which is going from point R1 to point R2 is the EIP R12 divided by h bar R12, and P square by 2m will be the kinetic energy of that particle. So this is how we combine amplitude, and this is for the single particle in the free space. And the relationship between momentum and energy of that empty particle is Pc is equal to E square minus m naught c square whole square, or P is equal to E square m naught c whole square divided by c. So this is the relationship between momentum and energy of that free particle. And in the next video we will explore more about this amplitude.